Okay, gonna solve these problems for you right now. Gonna do it the same way. Let's check out problems. All right. So on this side we have the variables p, v, and r, t. It's important to remember that we always know r 0.0821, 22 grams of carbon dioxide. Well, that's not in moles, 2.2. So we're gonna put 2.2 grams there, and we're gonna be looking for moles of that. 250 milliliters. That's not in liters. So we're going to put that there, looking for liters. 0.98 atmospheres. Now that is in the unit we want. And they're looking for the temperature in Kelvin. And then later they're going to ask us to convert it to degrees Celsius. But this Kelvin here is the first one we're looking for. So let's convert this. Remember, we just divide that by 1,000. So that's going to be 0.250 liters. No problem there. Now, 2.2 grams. Well, we know that the molar mass of carbon dioxide, okay, we're going to do that. This is 44 grams in every 1 mole. Well, if you have 2.2 grams, how many moles would that be? Well, 22 is going to be 0.5, so this is going to be 0.05. Okay, and now we're going to go ahead and solve this. So if PV equals nRT, and they're looking for T, okay, we're going to divide both sides by... Why am I struggling here? I'm having total algebra brain farts. Well, solving for T. So we got to isolate T. So divide both sides by NR. Jeez. So T equals PV divided by NR. So P is 0.98. V is 0.25. N is, ooh, that should be there, 0.05. And R is 0.0821. So we're going to get an answer that's going to be in Kelvin. Okay, so let's go ahead and do that. So we're going to do 0.98 times 0.25 equals that, divided by 0.05. Now I got to hit equals here, divided by 0.0821 equals there. So that is going to be 59.6. We call it 59.7. 59.7 Kelvin. Okay. Now, if I have degrees Celsius plus 273 equals Kelvin, okay, then degrees Celsius equals Kelvin minus 273. So if I take Kelvin minus 273, so 59.7 minus 273 equals negative 213. Negative 213.3. Negative 213.3 degrees Celsius. All right, number 4. So, boom. P, V, N, R, T. 10 grams of hydrogen gas. Okay, so again, that's not in moles. So 10 grams, and we're going to be looking for the answer in moles. 100 mils, that's not in liters. So 100 mils, we're going to be looking for the answer in liters. Pressure 0.95. Atmospheres, that's fine. We know that R is always 0.0821, and they want it in Kelvin and degrees Celsius. So Kelvin and degrees Celsius, just like last time. So if, let's do the mole conversion, it's hydrogen. We know that hydrogen is 2 grams in every 1 mole, but 10 grams in every X moles. So X equals 5 moles of hydrogen. So that's going to be 5 moles. We just divide that by 1,000. So that's going to be 0.1 liters. So if PV equals nRT, and they want T, we're going to divide both sides by nR. So T equals PV over nR, which equals 0.95 multiplied by 0.1 divided by 5 multiplied by 0.0821. 0.0821. Okay, so then I'm going to do this in my calculator again in front of you. So 0.95 times 0.1 equals divided by 5 equals divided by 0.0821 equals. Okay, so now I'm going to do equals point. This is really, really cold. 0.23. Really, 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 really cold. To get something as ideal as hydrogen to occupy a small volume like that, you're going to have to get it really cold. So 0.23 Kelvin, and then if I subtract that, it's almost as at absolute zero, minus 273 equals negative 273. Negative 273, or I'm sorry, let's do it right. Negative 272.8. Negative 272.8 degrees Celsius. So there's Kelvin. There's degrees Celsius. Remember, what I did is I just subtracted out 273 from Kelvin to undo that. Number 5 is the last one here. So P, V, N, R, T. We know that this is always 0.0821. What is the gas's temperature in degrees Celsius? So remember, we got to get it Kelvin first. It always comes out in Kelvin, okay? Volume of 25 liters, 203 moles, so a ton of moles. Now notice, volume was given in liters. Oh, and I have my pressure, 143.5 atmospheres. So I have a huge pressure, a ton of moles in here. So this is going to be probably a very low temperature. So I have 203 moles. That's a lot of moles. So to get that to occupy 25 liters, my hypothesis is that it's going to be pretty cold. But back to my point, since the pressure was given in atmospheres, the volume in liters, moles, not in grams, we're not going to have to do any conversions up front. We'll be doing those conversions at the end, obviously, to get back to degrees Celsius. But again, we're solving for T, so to undo that, we divide both sides by NR. So T equals PV divided by NR. P, 143 atmospheres. B, 25 liters. I think the liters there. N, 203. And R, 0.0821. So let's do this out. Let's see what we get. So remember, the answer is going to come out in Kelvin because Kelvin is the unit that our equation is based in. So 143 times 25 equals that, divided by 203 equals that, divided by 0.082. Oh, whatever. It's just supposed to be 0.0821, so my number's going to be a teeny bit bigger than yours. Whatever. Equals that. Okay. I know. Let's do it again. Let's do it again. I'm not going to be lazy. 143 times 25 times. Ah! Come on, Ramsey. 143 times 25 equals divided by 203 equals divided by 0.0821 equals. That's our Kelvin value. I'm going to subtract 273 equals negative 58. Okay, so this is negative 58. Well, let's get it right. Negative 58.5 degrees Celsius. Now Celsius, because we already went through and subtracted out 273.